Hi everyone, this is our third example in the series on circles and chords. So in example 3, we've been asked to find the equation of the circle having AB as a chord, where A is a point 23 and B is a point 50, and the tangent to the circle at point A is the line y equals 2x minus 1. Okay, so the first thing we can do here is we can identify that C is the center of our circle, and there will be a radius from A to C. So we can find the equation of a line passing through A to C. If I just draw this in purple, and we'll call this line L1. We know the angle between a tangent and a radius is 90 degrees, so these two lines will be perpendicular, which means the gradient of line L1 will be the negative reciprocal of the blue line. So this will be y equals negative 1/2 x. And we know that on this line, it passes through point A at 2 and 3. So for L1, we can use the equation of a line. We've got negative 1/2 multiplied by x minus 2 will equal y minus 3. We can expand out the brackets and move this division of 2 to the right-hand side. So therefore we get negative x plus 2 will equal 2y minus 6. So the equation of line L1 will be negative x plus 8 divided by 2 will equal y. Okay, so the problem we have now is that we need another line that passes through L1 and through the center, and we can work out this line by finding the line segment of A to B, and then having a perpendicular bisector through this line segment. So if we draw a chord from A to B, and we can work out the gradient of this chord, this will be the change in y, so 3 to 0, so negative 3, over the change in x from 2 to 5. This will equal negative 1. So the perpendicular bisector through chord A to B, this green line, we'll call this L3, will be perpendicular to a blue line, and this will have a gradient, which is the negative reciprocal of this, so positive 1. But now we need to find the point when this line passes through, and that will be the midpoint of our chord A to B. So we can work this out by finding the average of the two x values. So 2 add 5, 7, divide that by 2, we get 3.5. And the average of the y values, so 3 add 0, divided by 2, and 1.5. So now we can work out the equation of a line L3. It'll be the gradient of 1 multiplied by x minus x1, and that will equal y minus y1. So we'll get rid of these brackets, and then we'll move this negative 1.5 to the left-hand side. So line L3 will be y is equal to x minus 2. Now we can see that line L3 and line L1 intersect at the center of our circle. So we can work out this coordinate by solving L1 and L3. So negative x plus 8 over 2, which is L1, will equal x minus 2. We can move this division of 2 to the right-hand side. The negative x plus 8 will equal 2x minus 4. So 3x must equal 12, which gives us x will equal 4. So the center of our circle will have an x coordinate of 4. We can substitute this then into our equation for L3, and our y value will be 2. So now we have the coordinates for the center of our circle, but we need to find the radius. And we can do this using point A and the center. Because we have this center, we can have a right angled triangle from A to C. Now we have our right angled triangle. We know the base will be the distance between 2 to 4, the height from 2 to 3. We can use Pythagoras' theorem to work out the radius of our circle. And this will be the square root of 5. So finally, the equation of a circle will be x minus 4 squared plus y minus 2 squared will equal the radius squared, so 5. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.